Okay, so this was our question. F of x is equal to mod x, and we want to prove that this is f dash of x is not differentiable at x equal to 1 and x equal to 2. Okay, so this is the question. So now what we need to do is we want to prove. So let's use the definition of differentiation. So f dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. Correct. So we want to prove at x equal to 1 it is not differentiable. X equal to 1 it is not differentiable, we want to prove. Correct. So first step is what? You have to find out f of 1. How much is f of 1? So f of 1 means greatest integer of 1, that is equal to 1. Okay, after that what you have to do? You have to write the same statement, this again. Correct. This thing you have to repeat. Wherever you have x, you have to replace it by 1, because at this point you want to prove at x equal to 1 you want to prove it is discontinuous. Correct. So wherever you have x, just replace it by 1. Okay, it is equal to 1. Okay, then what we can do? Then we have to now see here, let's first find left hand limit. So h tends to 0 minus. Okay, so now in greatest integer function, whenever you are approaching from the left, what happens? Your whatever value is there, right, the integer part will be reduced by 1. Correct. So in this case, what is f of 1? F of 1 is equal to 1. Correct. And 1 plus h is approaching from the left. Correct. So what happens to the value? It will be reduced by 1. Correct. So if this is your 1, if this is your 1, okay, if you are approaching from the left like this, so what happens? So the value will be reduced by 1. Correct. So your answer would be 0 if it is your, if your f of x, if x chosen is 1. So here what happens? This f1 plus h, it will be equal to 0. Correct. Then divided by h, and you have to write this also, limit h tends to 0. H tends to 0 minus. So if I apply the limit now, minus 1 by 0, it's not defined. Correct. So infinity, it's not defined. Correct. So let's find out. Here itself you can conclude it. Still let's find out right hand derivative. So it's not limit, okay, it's derivative. So right hand derivative f dash of 1 limit h tends to 0 plus f of x plus h minus f of x divided by h. Correct. So in this case, now see, it shouldn't be x. Wherever you have x, you have to replace it by 1. Okay, so now we know what is f1 value. Correct. So this value is equal to 1. And what is this value? So now see, now h is approaching from the right. Correct. So it's like 1 point something. Correct. 1.00 something, like that it is. Correct. So the value will be that value itself. If for greatest integer function, if something is approaching from the right, then the value will remain that value itself. Correct. So here what will be the value? So is it, should I write 1 or should I write this? Yeah, so it will remain as 1 itself, correct? 1 plus h is a minute value, 0 point something, approaching from the right, correct? Positive value. So it is 1 itself divided by h. Okay, now you have to write this also every time. Limit h tends to 0 plus. Okay, now what we got? It is limit h tends to 0 0 by h. So now 0 by anything is 0, correct? So I can just tell it is equal to 0. Okay,
So,
so you can see a left hand derivative, however it is not defined, right hand derivative not defined. So at x equal to 1, not differentiable.
so,
Ah, yeah,
so, why don't we take h as 0 in the right hand derivative?
yeah, you can take like that.
No, then it becomes not defined, right?
Yeah, even this is also not defined.
Then it should be differentiable.
uh no, see, what you know, if you get a finite number over here on the right hand side, if you get finite number on the right hand side, okay, and those two finite number are equal, then only it is continuous. So see, on the right hand side, if you get any complex number, or if you get infinity, or any indeterminate form, then it is not continuous. Okay, so even
Okay,
though,
sir.
yeah,
Okay, sir, I got it.
uh, yeah, so here left hand derivative is not equal to right hand derivative. So similar procedure you can apply for when x is equal to 2. So when x equal to 2, you can do the same procedure. Okay, so what you can do is f f2 you find out how much it is. Okay, so find out f of 2 is equal to how much. Okay, once you get f of 2, then just substitute those in the limits definition, solve it, you'll get your answer. Okay, even that will be not differentiable also. Okay, so for x equal to 2, you have to try it. Okay, is it fine?
Yeah, sir.
Okay. So now let's move to the next topic. It is called implicit differentiation. Okay, so there are two types of function. One is explicit function, another one is implicit function. Explicit, and there is implicit. Okay, so now I will take two examples. Okay, so one example is x minus y minus pi is equal to 0. So now, can I separate x and y? Yes, I can write the relation of y, a relation of x in terms of y, correct? So I can write it in this way: y is equal to x minus pi, x minus pi, correct? I can write it in this way, correct? So these kind of function which you can separate easily, those kind of question, those kind of equation are called, or those kind of function are called explicit function. So you can represent in this form: y is equal to f of x. Okay, those kind of function are explicit function. But see, if I give one example in this way: x plus sin xy minus y is equal to 0. So this equation can you separate x and y easily? So if you want, you can try to do it. Y is equal to x plus sine xy, you will get. But see, there is xy in the inside the sine, correct? So to separate it, what you might do, so if you want to separate it, in case I'll just do y minus x is equal to sine y, sine xy. So if I want this xy, so if I send sine to the other side, what happens? It becomes sine inverse, correct? Y minus x. So however, if you try, it is very difficult to separate x and y term, correct? So these kind of question, these kind of function which are very difficult to separate, or sometimes it cannot be separated, those kind of function are called implicit function. Okay, so you understood, no, what is implicit, what is explicit function?
Yeah, sir.
Okay, now see, if we want to differentiate implicit function, we have to use its own procedure. Okay, so now I will, let's take one example. So if I have this function, this is very easy to differentiate. So how can we differentiate this? So you can rearrange the whole expression in terms of y, then differentiate with respect to x. Dy by dx is equal to 1 minus 0, correct? Differentiation of constant is 0, equal to 1 we got, correct? So here, or else what we can do is, the same question is there, right? X minus y is equal to pi. Differentiate on both sides. Okay, I'm doing the same thing again. So that's equal to, differentiation of x is how much? 1, correct? Minus differentiation of y is how much? Dy by dx, correct? And differentiation of constant is how much? 0, correct? If I rearrange it, even I will get the same. Dy by dx is equal to 1. Okay, so see, here you could rearrange it and find the derivative, or else you could just find the derivative on the both side. Okay, so now see, this is easier for some cases. Okay, every time if you try to do like this, no, what happens is sometimes you cannot separate it. Okay, that's why we are going to follow this method, differentiate on both sides. Okay, so here you need not to represent x in terms of y or y in terms of x. Here you directly you can differentiate on the both side. In this method, what happens, since this was the easier function, you could separate and write y in terms of x, correct? So every time this process might not be easier, whatever I did over here. So we'll try to avoid this procedure in our upcoming problems. Okay, so this was one of the example. So let's take another example. So if you have to find what is dy by dx if y plus sin y is equal to cos x. Okay, so note down what is the procedure. Okay, so first thing what you have to do is differentiate on both sides. On both sides. Okay, so what is differentiation of y? It is dy by dx. Okay, so now this is important. How do you differentiate sin y? So differentiation of sin y is cos y. Okay, how you write sin x? Cos x, correct? In the same way, sin y is cos y. But see, there is another term, correct? Y. So of y is also you have to write the differentiation. What is the differentiation of y? It is dy by dx. Then what is the differentiation of cos x? Cos x is minus sin x. Okay, so has this chapter started in your college?
Yeah, sir.
Till where they have did? Till which exercise they have reached?
So they reached to 5.4, I think.
5.4. Okay, so you might be familiar with all this. Okay, so So I might skip some steps in between. Okay, so for some steps I will do it directly. So if you don't understand, you ask me. Okay. Yeah, so I think you all are familiar with these and all. So I will just level up. Yeah, so now what I can do is I will just take dy by dx as common. So 1 plus cos y is equal to minus sin x. Then what you have to do is you have to subtract all your answer in terms of dy by dx, that is equal to 1 plus cos y. Okay, so did you understand no procedure what you have to follow? So first what you have to do is differentiate on the both side. So while you are differentiating any function of y, what you have to do is differentiate as you differentiate for x with respect to x. But whatever term is there no inside y, you have to differentiate once again, apply the chain rule. Okay, at the end you have to write dy by dx. Yeah, so this is the procedure you have to follow. Okay, now yeah, let's go to what if you have how would you differentiate a inverse trigonometric function? So see, honestly, even I forget if I am asked what is differentiation of sine inverse x. Okay, so it's not possible for me to every time remember what is the formula for this. Correct. But see, you can derive it usually. So imagine my y is equal to sine inverse x. So what is my dy by dx? How can I derive it? Okay, so what I will do is, we know what is differentiation of sine x, correct? But we don't know what is the differentiation of sine inverse x. So let's use that property of sine x. So here what I can do is, see, you can look at this equation, right? So here if I send the sine inverse to the left hand side, what happens? It will be x is equal to sine y, correct? Now this is an implicit function, correct? As your as it was before. Now what you do is differentiate on both sides. Okay, differentiate on both sides. So what you will get? Differentiation of x is 1. Differentiation of sine y, it is cos y, correct? But here, since it is a function of y, you have to write dy by dx. Okay. Now, next what we can do is dy by dx is equal to 1 by cos y. Okay, so now we want to try to convert that cos y in terms of sine y. So what I can do is, so I know the relation between sine and cos, correct? So sine square x plus cos square x is equal to 1, correct? So instead of cos y, I can write like this, 1 by square root of 1 minus sine square y, correct? So what is my sine y equal to? Sine y equal to x, correct? So sine square y is equal to minus x. Sine square y is equal to x square, correct? So here, therefore dy by dx is equal to 1 by square root of 1 minus x square. So by applying the similar process, you can derive for other trigonometric functions. Okay, so other trigonometric function can be solved using the same method, correct? Okay, so here let's try to derive a formula for y is equal to tan inverse x. So you could understand no how I derived this sin inverse x formula. So do you have any doubt in this? No, right?
No, sir.
Okay. So same procedure you have to apply for this also. So x is equal to tan y. Now dy by dx is equal to how much we want to find out, correct? So now for this equation, differentiate on both sides. So 1 is equal to differentiation of tan y is secant square y dy by dx. Now dy by dx is equal to 1 by secant square y. So I want to represent secant square in terms of tan. So what is the formula? Secant square y is equal to tan square y plus 1, correct? So we have basic three identities, correct? So if I have sine square plus cos square equal to 1, so now what I will do is divide by cos on both sides, divide by cos square on both sides. If I do cos square, cos square, so what I will get, tan square plus 1 is equal to, here 1 by cos square is secant square, correct? So secant square I have replaced by tan square plus 1. Yeah, so what is my tan y is equal to? It is equal to x. So dy by dx is equal to 1 plus x square. Okay, so this is for tan. So now can you find out for this y is equal to, let's take secant inverse x. Okay, dy by dx. Okay, so derive the formula for this and tell me the answer. So we can apply the same process. So did you understand what all steps I followed?
Yeah, sir.
Okay, so in this way you can derive any of this. Okay, so now for sine inverse x, what was the formula? 1 by square root of x square minus 1, correct? So for cos inverse x, the formula is minus. Okay, so in the case of tan inverse x, what was the formula? 1 by 1 plus x square, correct? For cot inverse x, the formula becomes minus. And for secant inverse x, your formula was this, correct? 1 by x root of x square minus 1. So for cosecant inverse x, the formula becomes negative. That's it. Okay, rest everything is same. So you can apply the same procedure to derive those also. Yeah. So now, so let's solve some easy questions. Let's move to exercise 5.3. find dy by dx in the following. So let's solve the first question. 2x plus 3y is equal to sin x. So what is the first step? Differentiate on both sides. Okay, so differentiation of 2x is 2. What is differentiation of 3y? 3 is constant. Differentiation of y is dy by dx. What is differentiation of sin x? It is cos x. So now what you have to do? Rearrange everything in terms of dy by dx. So cos x minus 2 by 3. Okay, this is our answer. So here in the second question, instead of sin x, they have given sin y. In second question, instead of sin x, they have given sin y. So now how can we solve this? So instead of cos x, what would be the answer here? Cos y dy by dx, correct? So here the final answer won't be in this way. Yeah. So now how we have to do? We have to solve this in such a way that dy by dx should be at one side and other terms x or constant should be at the other side. So now what I can do is here I will make a group of like terms. Minus 2, then dy by dx is common, correct, which is equal to minus 2 divided by 3 minus cos y, correct. So is this answer correct? Yeah, minus 2, yes, it's correct. So in the textbook what they have done is they have sub multiplied both side, multiplied numerator and denominator by minus 1. Okay, in that case you will get your answer in this way, cos y minus 3. Okay, that's the answer given in the textbook. Okay, so answer is correct. Okay, so let's question number 3. Question number 3, will you get any difficulty to solve question? Okay, question number 3 I will explain you. And the question number later all the questions are similar. So ax plus by square is equal to cos y. Okay, this is our question. Now see, first step is differentiate on both sides. Okay, so you have to differentiate on both sides. So how can you differentiate now? So differentiation of ax is a. What is differentiation of by square? So b is constant. Differentiation of y square is 2y dy by dx. Cos y. What is the differentiation of cos y? It is minus sin y. Then you have dy by dx. So I will make a group of dy by dx. So dy by dx is equal to minus a divided by 2by plus sin y. Correct. This answer is correct, right? So I'll just check in the textbook. Yes, it's correct. So in this way you can solve. So let's look at the question number 4. So question number 4 is similar. So I think you can solve it. Question number 4 you can solve it, right? Differentiation of y square you can do. Tan x differentiation you know. And y differentiation of y is dy by dx. So question number 4 is easier. It's not that much difficult. Okay, so question number 4 you have to do it by yourself. And question number 5 is also easier. Same method whatever we followed earlier. And even question number 6. See, in the question number 6 you have to note this here. There is x cube and there is x square y. So if you have something term like this, how would you differentiate this term? So this is my question, right?
So can we use the product rule?
Yes, you have to use the product rule. Okay, so if you don't use the product rule, then you whatever answer you'll get it wrong. Okay, so the question is in this way. So here differentiation of x cube, you know, it is 3x square. Then here what you have to do is you have to use product rule. So first function into differentiation of second function dy by dx plus second function into differentiation of first function, it is 2x. Correct. Same thing you have to do it for this also. First function into differentiation of second function plus second function into differentiation of first function. So second function is y square, differentiation of x is 1. Correct. Then y cube. So it is 3y square dy by dx, which is equal to differentiation of constant is 0. Yeah. So now what you do is simplification. So here this term has dy by dx, this term has dy by dx, this term has dy by dx. So dy by dx into x square plus 2xy plus 3y square. So here 3x and this term doesn't contain dy by dx with it, right? So is equal to minus of 3x square plus 2xy plus y square. Correct. So next we want the answer in terms of dy by dx. So dy by dx is equal to so you understood this, right? How to solve these kind of problems.
Yes, sir.
So now question number 7. How can we solve question number 7? So the question is sine square y cos of xy is equal to k. Okay, so now see here inside it is function of both x and y, correct? So if you have the problem in this way, so cos, you have to differentiate as it is. So cos differentiation is minus sine, correct? And after that, how can you do? Then what is inside, differentiate that. Okay, so let's solve that. So exercise 5.3. So what is differentiation of sine square y? It is 2 sine square y. Then sin x is differentiation is cos x. So here cos y, then differentiation of y, it is dy by dx, correct? And cos xy, how can you differentiate? Cos xy is minus sin xy, correct? Then differentiate whatever term is inside. So differentiation of xy, so you have to use product rule, correct? So after using the product rule, you will get the respective derivative. Okay, let's solve it. So 2 sin y, then into cos y, correct? Then dy by dx. Here cos y's differentiation is minus sin xy, correct? Then whatever term is inside, that's derivative you have to do. That is equal to first into differentiation of second plus second into differentiation of first. Second is y, differentiation of x is 1, correct? And see what is on the right hand side, it is a constant k, correct? So which is equal to 0. Yeah. So now what we can do, so here there is a formula, see, 2 sin y cos y, 2 sin y cos y is sin 2y, correct? Trigonometric identity. So wherever you can simplify, you try to apply the identity which you know. Into x dy by dx minus xy equal to 0. So now what else I can do? So here in this both term there is dy by dx common, right? So let it be on the left hand side. This term I will send it to the right hand side. Okay, this term I will send it to the right hand side. So in that case what happens? This becomes positive, correct? So here it becomes positive. So I will just remove this 0. Yeah. So after that, just take dy by dx constant, uh, not constant, common outside, which is equal to y sine So did I miss anything? No. Okay, so this is our required answer. So I'll just check in the textbook whether the final answer is given in this form or not. Yeah, they are given in this form. So you could understand now how to solve this. So now question number 8 you have to try by yourself. Okay, same process you have to do. Question number 8, I don't think that is much difficult. Okay, question number 8 you have to do by yourself. Yeah. So now from question number 9 to question number 15, it is inverse trigonometric questions. Inverse trigonometric kind of questions. Okay. So see, for inverse trigonometric function, if they give some, so you know the this for you know the derivative for standard functions, correct? Tan inverse x and all, you know the derivatives. But see, what if they give complicated term inside it? So there is one question in this way. Okay, so y is equal to sine inverse 2x, so one second, 2x by 1 plus x square. So now you have two options. Okay, so one option is what you know the standard function, right? Sine inverse x, what is its answer? 1 by square root of 1 minus x square, correct? So what you can do is you can apply the same definition over here, which is equal to 1 by square root of 1 minus whole square. Then what is differentiation of this? 2x by 1. Then differentiation of this, you have to use quotient rule. Then what you have to do is, after using the quotient rule, you have to solve it. So here this process becomes quite complicated. Okay, even though final answer whatever you get is same. Okay, so see, if you are interested you can try with this method. Okay, so see, there is some alternative for this, the same kind of question. So y is equal to so if the question is in this way, so there is some alternative for this. So now see, here we have to use a special method called parametric substitution. Okay, so according to this method, what you have to do is, whatever x is there, no, you have to replace with such a function so that you can simplify this easily. Okay, so now you know this, see, what we want is inside. So what we are trying to do is, here there is sine inverse term, correct? We want to bring the sine term inside it. Okay, so we want to bring it in this way, so that what we can do is sine inverse and sine will cancel. What is remaining? It is theta. So now you just differentiate d theta with respect to dx. Okay, that will be your answer. Okay, so we want to solve this same problem in this way, correct? So now what we know about this formula, we want to bring sine function inside this. How can we bring? Okay, so do you know the function sine 2x? Sine 2x, what is the formula? 2 sin x cos x, correct? So if nothing is there, it means there is 1, correct? So 1, how can we write? Cos square x, correct? So now next step, what I will do is divide by cos square x on both sides. Okay, on the numerator and denominator I will divide by cos square x. So here 2 sin x cos x divided by cos square x. Here what happens? Sin square x plus cos square x by cos square x. So if I simplify this, so 1 cos will cancel with cos. So in above what has remained? 2 tan x, correct. And here in the denominator, sin square plus cos square is tan square x, correct. And cos square x by cos square x is 1. So see, whatever term we can see over here, 2x by 1 plus x square, it is identical to this formula, correct? Sin 2x formula. So this is sin 2x formula in terms of tan, correct. So whatever x is there, no, it is identical to this formula, correct, sin 2x. So what is our strategy is, we are going to simplify this. So 1 plus x square, right? Yeah. So here what is our first step is, we know what we have to substitute for x. So let x is equal to tan theta. Next step what is there? Wherever you have x, just substitute it. Sin inverse of 2 tan theta. Okay. So this is the formula for which function? It is sin 2 theta, correct. Now what happens here? Sin and sin inverse and sin will cancel. What is left? Y is equal to 2 theta is left, correct. So what is theta from here? So implies theta is tan inverse x, correct. So here it is 2 tan inverse x. Okay. So do we know the formula for tan inverse x? Yes, we know the formula, correct. So dy by dx is equal to 2. Tan inverse x is 1 by 1 plus x square. So this is our required answer. Okay. So if you do it in other way, whichever I told you, so wherever you have this whole square, then quotient rule. Quotient rule says that denominator square, second into differentiation of first, into first into differentiation of second, minus first into differentiation of second. So if you do with this method also, you'll get the same answer. Okay, so if you want to try, you can try it. So this is how you solve. Yeah. So do you have any doubt in this method? So you can even solve with this method also, no issues, but it will be complicated, that's it. So this you can simplify. So do you have any doubt? No, right?
No, sir.
Okay. So let's try question number 10. So question number 10, y is equal to, okay. So here, what is the suitable substitution for x? So here the suitable substitution for x is tan theta, correct. So this is the formula for tan 3 theta, correct. So tan 3 theta is equal to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Correct. So in your first PU you have studied this and you know how to derive it also, right? So tan 3 theta, how can you derive? Tan 2 theta plus theta. Correct. Then tan x plus y formula you have to use. So tan x plus y would be somewhat like this. Correct. Tan A plus tan B divided by 1 minus tan A tan B tan theta. So in the place of tan theta you have to substitute the formula of this again, tan 2 theta's formula. Tan 2 theta's formula is 2 tan theta divided by 1 minus tan square theta. Correct. Plus tan theta. So if you solve this and simplify you will get this answer again. So it is easy to verify. Okay. Yeah. So wherever this is there, so tan 3 theta formula we know. So implies yeah. Now so here wherever x is there just substitute tan theta. Tan inverse of yeah. So now what we can do, so this is the formula for tan 3 theta. Correct. So y is equal to tan inverse of tan 3 theta. Correct. So tan inverse and tan will cancel, just 3 theta is left. Okay, so what is theta? Theta is equal to tan inverse x, which is equal to 3 tan inverse x. So dy by dx is equal to x square. Okay. So you understood this, right? How to solve this kind of problem. So if you have any inverse trigonometry kind of problem, just do the suitable substitution, then you will get your answer. Okay. Yeah. So do you want to take break? So shall I continue or do you want a 5 minutes break?
So can you
Can we
give it
get
a
a
minute?
5 minute?
Yeah, yeah. Okay. So we'll take a short break. Okay, then we'll continue. Shall I continue? So now question number question number 11 will solve. So the question number 11, what does it say? Question number 11 is y is equal to cos inverse of 1 plus x square. So see, if here there is cos, right, cos inverse. Inside you have to try to get cosine term, correct? So how can you do? So here what you have to do is cos 2x formula, do you know, right? You know cos 2x formula. So it is cos square x minus sine square x. Okay, so this, if nothing is in the denominator, what does it mean? It means there is 1 in the denominator, correct? So 1 I can write it as, okay, so let us write the cos term in the beginning. Cos square x plus sine square x, correct? And if I divide by cos square on the both sides, so what it will become? It will become 1 minus tan square x divided by 1 plus tan square x, correct? So is this formula related to this? Yes. So our suitable substitution is x is equal to tan x. So y is equal to, yeah, so let's write properly. So y is equal to, so x is equal to tan theta is our suitable substitution. So theta is equal to tan inverse x, correct? So here let us substitute. So y is equal to cos inverse of 1 minus tan square theta 1 plus tan square theta, which is again equal to cos inverse of cos 2 theta, correct? Now cos inverse function and cos function will cancel, so y is equal to 2 theta, correct? So what is our theta? Theta is equal to tan inverse of x, so 2 tan inverse of x. So therefore dy by dx is equal to, what is tan inverse x formula? It is 1 by 1 plus x square. So 2 was already in the numerator, so this is our required answer. So in this way we can solve. Okay, so now just look at the question number, just now we solved question number 11, right? Question number 12. So now question number 12, what is the suitable substitution? So here in question number 11, the question was cos inverse of something was there. So in the question number 12, what they have done is cos inverse they have changed into sine inverse. Okay, and we clearly know if we substitute tan theta, it is the formula for which function? Cos, correct? So do we have any alternative for this? So see, this is question number 12. Is there any another way we can solve the same problem. Should we use some other substitution method? So here also, if you have the question, it is in this way. You know, if you substitute tan theta, you will get in terms of cos, correct? And sine inverse and cos you cannot cancel, correct? But see here, what is the strategy is, you know how to convert cos into sine, correct? You have to use odd functions, correct? So cos 90 plus cos 90 minus, correct? It will be in terms of, so you have to use odd functions. Yeah, so let's solve this how it is. Okay, so this is our question, correct? So let the substitution be same. We are not doing any changes. There is sine inverse. Okay, so from the next steps the answer would be changed. Yeah, so now if I solve this, what I will get? Sine inverse of cos 2 theta, correct? So now cos, how can I write in terms of sine? So it is my, I have to write in terms of odd angles, right? So in which quadrant? So here you have to be careful, okay? So in which quadrant you have to see sine is positive. No, no. In which quadrant cos is positive you have to see. So in which quadrant cos is positive? In the first quadrant cos is positive. This value is already in the first quadrant. So in which quadrant? If you write 90 plus, what happens? 90 plus 2 theta. The value will be negative, correct? 90 plus theta, if you write, the value will be negative. If you use minus, then cos term will be positive, correct? So it will not alterate our this function. Yeah, so now what is the suitable substitution is sine 90 minus 2 theta, correct? See, you can either write this also 90 plus 2 theta, no issues. Okay, but there is a problem. What you have to do, you have to introduce minus sign here. Okay, only that is the difference, rest all are same. Okay, so if you want I can do it in both methods also. So you understood now why I took sine pi by 2 minus 2 theta, because in this quadrant cos is positive. Okay, so if I am writing using this quadrant 90 plus, then I have to introduce a extra negative sign. So I wanted to avoid that. Okay, however if we do in any method we will get the same answer. So now y is equal to what we got finally, pi by 2 2 theta. So what is theta? Theta is equal to tan inverse x. Correct. So now differentiate on both sides. So when you differentiate on both sides, differentiation of this is constant, correct? It will be equal to 0. Differentiation of 2 is constant. Differentiation of tan inverse x is 1 plus x square, correct? So my answer is, my required answer is dy by dx is equal to minus 2 by 1 plus x square. Okay, so I will solve it in another method also. So here y is equal to y is equal to sine inverse of, what if I use, so this was our function, right, cos 2 theta. So I want to convert it to sine function. So if I use 90 minus 90 plus plus 2 theta. So what I have to do is I have to check is, so 90 plus, it is in second quadrant, right? So in second quadrant, sine and reciprocal of sine is positive, rest all are negative. So I have to put a negative sign over here. Okay, so y is equal to minus of sine inverse sine plus 2 theta. Correct. So now if I open this bracket, sine and sine will cancel, sine inverse and sine will cancel. So minus pi by 2 minus 2 theta. Correct. And what is 2 theta? 2 theta is equal to 2 tan inverse x. Correct. So differentiate on both sides. This is however a constant, so it is equal to 0. So 2 by x square. So see, we got the same answer again. Correct. So you have to be careful, okay, while solving. Yeah. So what if you didn't put this sign? Then it would be, your final answer would be in terms of plus. Correct. Okay, so that's why it is important what coordinate you choose. So you understood this, no? If you get these kind of problem, how to solve sine and cos inside, just convert it into sine function by using odd functions. Okay, so you know the concept of odd functions and even functions, right, in your first PU? See, if you write pi plus something, okay, it will convert into even function. So whatever you get is again sine of something. Okay, so odd function means pi by 2 plus or minus. If you do, you will get in terms of odd functions. It is sine's odd function is cosine, like that. Yeah, so in this way you can solve this problem. So let's move to the which question. So question number 13, can you solve it?
Yes, sir.
So what will be the suitable substitution over there? So which formula it is?
Tan.
Tan,
It's
yes.
for sine 2 theta.
So you will get sine 2 theta, yes. So sine you have to convert it to odd functions, correct? So you have to convert into cos function. So you have to be careful at which quadrant the sine is positive. So it will be in the first quadrant. So like this, plus 2 theta. Then rest everything is easy. Yeah. So question number 13 is a homework for you. Question number 14. So in question number 14, how can we solve this? So let's try to solve question number 14. So here you have two choices, okay. Either you can use substitution x is equal to sin x, sin theta, or you can use cos theta also. Okay. So here what is our aim, we want to bring sine function inside here. Okay. And what sine function we know is sin 2 theta is equal to 2 sin theta cos theta. Correct. So see, if you substitute one of the value, you will get your answer here. So this is easy, not that much difficult. So here the substitute x is equal to either sin theta or cos theta. 2 sin theta sin square theta. Correct. So this 1 root of 1 minus sin square theta is cos theta. Correct. And this whole term will be equal to sin 2 theta. Correct. So therefore sin and this will cancel, 2 theta. So what we chose as x is equal to sin theta we chose, right? So theta is equal to sine inverse x to sine inverse x. Okay, now what we can do, differentiate on both sides. So this will be our answer. Okay, so this is one of the easier question. Okay, now question number 15. Okay, this might be one of the difficult question. Okay, it's not that much difficult also, but still it can be trickier. So question number 15, what we can do, what is the suitable substitution over here? So see here, the question they have given is secant inverse, correct? Secant inverse of 1 by, so this is our question. Y is equal to this. So see, what I am trying to do here is, so what I want here is, I want some function such that 1 by, I want cos, correct? So if I take the reciprocal of it, what it will become? It will be equal to secant, correct? So I want to try to convert in secant inverse, so I can cancel it. Secant inverse of secant, theta, secant we can cancel and theta will be left. So we want to solve those functions in such a way. Okay, so here what is the suitable substitution over here? So we know the formula of cos 2x, correct? Cos 2x is equal to sin square x. So there are different form of cos 2x, correct? So I can write it in this way also, 2 cos square x minus 1, correct? So do you know this formula? This formula you know, right? It is basic formula. So do you know to convert this formula to this formula? Correct. So wherever sign is there, you substitute 1 minus cos square x, correct? So if you substitute and solve it, you will get this identity. If you want, you can try it. Okay, so here what we'll do is, we'll substitute x is equal to cos theta. Okay, so whenever you substitute it, so this what is there in the denominator, it resembles to cos 2 theta formula, correct? So y is equal to secant inverse 1 by cos 2 theta, correct? So y is equal to secant inverse, so cos 2 theta is, if I take the reciprocal, so 1 by cos is secant, correct? So it is secant 2 theta. So secant and secant you can cancel. So y is equal to 2 theta. So theta is what? So from this relation, theta is equal to cos inverse x. So differentiate on both sides. So this will be my answer. So did you understand the procedure? So if you get in this way, what you have to do?
Yeah, sir.
Okay then. So here our exercise 5.3 is completed. Okay. So now we'll move to the next topic. Okay, so next topic is exponential and logarithmic functions. So I'll just give you a brief idea about what is exponential function, what is logarithmic function. Okay, then we can solve the derivatives. So see, if you don't understand what is exponential, what is logarithmic, there's no meaning of solving the derivative of it. Okay, so let's understand what is logarithmic and all, then we'll solve the derivatives. So now I'll open my graph here, Desmos. So see, let's analyze some graphs. Okay, so here I will draw some curves. Y is equal to x. So y is equal to x is a straight line, correct? So what about y is equal to x square? X square. It's x equal to x square. Y is equal to, see, y is equal to x square is parabola. So see, do you know in this kind of software, it is actually, if you take mod also, it will not do much this changes. So here, if I don't want this negative axis, if I want the positive axis, there is some trick actually. So what I can do is, I can write it in this way, of square root of x. Okay, now see the negative half is removed. So in the same way I can modify this also. So it takes modulus only positive values. So we'll analyze with the positive value only. X square. So what went wrong? Yeah, square. So now see, this is the first straight line. You see, that is y is equal to x. The first red one, y is equal to x. This is y is equal to x square. Now the same thing. So y is equal to square root of x whole cube. Yeah. So this is y equal to x cube. Okay. So similarly, so what you can observe here, so this line is trying to move from here to, so first it is widened, correct? Second, you see, it is trying to move near the y axis, correct? So if I try y is equal to, so I'm doing this x and all, I just want to see, analyze the y coordinate, that's why. Okay, so x, only the positive axis, that's why I'm doing like this. Okay, x square to the power, yeah, 4. So you can see here, x, here it is more closer to y, it is trying to get inside, correct? So what I'll do is, see here, x, this is the graph, correct? X square. Okay, then if I have x cube, see, then if I have x to the power 4, and if I have x to the power 5, so if I have x to the power 6, so what you can observe here, the line is trying to shift inside, correct? Okay, so this was one of the observation. Yeah, so now let's see what is the definition of exponential function. So here these x, here x to the power 1, x to the power 2, x to the power 3, x to the power 4, and x to the power 5, and x to the power 6. So these 1, 2, 3, 4, 5, 6, what are those? Those are called exponents, correct? And let's see the definition of exponential function. So exponential function is defined in this way. The exponential function with positive base a, the exponential function with positive base p greater than 1 is the function y is equal to f of x is equal to b of x. Correct. So now this b means any positive number. Okay. So if you have like this, so y is equal to 3 to the power x. Okay. This is a exponential function. So whatever graph I showed you, no, what kind of function it is? So whatever graph I showed you, no, these kind of functions are called what? You are familiar with these kind of function, right? These are called polynomial function. Correct. And see, if I have graph in this way, 1 to the power x and 2 to the power x, 3 to the power, so it has become 2x, 2 to the power x. See, 2 to the power x graph you can see, right? And if I have 3 to the power x and 4 to the power x, so these kind of function, see here also you can observe the thing. So 1 to the power x line, 2 to the power x, 3 to the power x is trying to come closer to y-axis. So these kind of function what you see, these are called exponential function. Why exponential function? Because x is the exponent here. Okay. Yeah. So I hope you got the understanding of what is exponential function. So exponential function is such a function where there is a positive number raised to some power x. Okay. Usually we call that positive number as our base. Okay, we represent it by b to the power x. Okay, and this b should be positive. B is called base. Yeah. So did you understand what is this exponential function?
Yeah, sir.
Okay. Now see, you know about simple interest and compound interest, right? And okay, let it be. So you have used this e, correct? So do you know what is e? E to the power x, e and all we use, right? E to the power log x. Do you know what is this e? It is a constant, correct? So e is a constant. Okay, and e is a special kind of constant. Okay, so if you have ever searched the definition of what is e, exponential, okay, so it is such kind of function whose slope is equal to the function value. So if I have f of x, okay, so if I have f of x, if I take, if I, this is my function, so if I take the slope of this, okay, if I take the slope of this function at this point, okay, so my f of x and the slope whatever value I got, at both point it won't be same. But see, exponential function is such a function that at any point, if you find this, so f of x and you find out f dash of x, okay, so just imagine if you are finding x is for x is equal to 1, okay, for x equal to 1, if you do for exponential function, your f of 1 value whatever you get and your f dash of 1 whatever you get, it will be equal. Okay, so it is the speciality of the exponential function. So exponential function is such a function that whose value and its slope value are always equal. Those kind of special function are known as exponential function. Okay, let it be. So now imagine, I will tell you one short story. Okay, so imagine you go to a bank. go to a bank, okay, and you want to open your account. So now see, whenever you open your saving account, you will ask what is the rate of interest, correct? So more rate of interest means more money you will earn on your deposits, correct? So see, imagine you go to a bank and the bank manager is more generous towards you, okay, he wants to offer you 100% interest for 1 year on your deposit. So what does it mean is, if you deposit 10,000 in your bank account, after 1 year the money will be doubled, your money will be 20,000, okay, you will get 100% interest. Imagine this hypothetical situation, okay, this won't happen in your real life, but just imagine in this way, okay. Now see, do you know what is difference between simple interest and compound interest? So here, usually in our bank, whatever money we deposit, right, it gets compounded. So here, instead of getting interest in the end of the year, what they do is they give you interest quarterly. Quarterly means 4 times in a year. So for every 3 months, they will give you the interest, correct? So if you withdraw that interest, you won't get the extra interest. So what happens is, if I am depositing one rupees, okay, if I am depositing 100 rupees, so if the bank's interest rate is 4%, so for this I will earn 4 rupees per annum, correct? So if they do the compounding quarterly, so what happens? So whatever interest I am getting, no, 4 divided by this 4 times, correct? So after 3 months I will get 101 rupees, okay. So now the simple interest formula will run for this. So now next remaining 3/4 year is there, no, you will get the interest on this amount, okay. So here, instead of getting 104 as your final this money, you will get more than it will be around 106 or 107, like that, okay, it depends on the calculation. So now imagine this hypothetical bank which is giving you 100% interest for year, okay. And how do you come, see, there is one logic, more you compound, okay, more frequently if they give you the interest, the overall interest at the end of the year will be more, okay. So this is the compound interest formula if you want to find out. So compound interest, how much interest you will be going to earn. So a is equal to t 1 plus r by n to the power nt. So in from this series and all you have studied this, yeah. So now what is my principle? Imagine I have deposited 1 rupees, p is equal to 1, and my rate of interest is 100%, correct? 100% means 100 by 100, correct? So that is equal to 1. And see, I imagine I am compounding it for very long term. So more you compound is more interest you get, correct? So just imagine here, I say I am a little bit greedy, okay. I will tell them, you compound this money 10,000 times, okay. I will tell them to compound this money 10,000 times, okay. So in 1 year, how you compound is, monthly you can compound, you can compound 12 times per year, okay, or else you can compound daily 365 days per year. So I am telling him, like, for every 5 hours you compound the money, okay. So just I am telling, compound it 10,000 times, yeah. So now if I just, and my term is t is equal to 1 year. So what it is observed is, so if I just input all those values, a is equal to 1 into 1 plus rate of interest is 1, okay, let's take 100 for the timing, okay. So my time is 1 year, correct? So here n is equal to 100 into 1, okay. So what I am, so just calculate this and tell me the answer, what a you will get. A is equal to how much you will get. So if I go back, everything I wrote will be erased. got my calculator. So 1 plus x to the power x is equal to, so if I put 100, what answer I got? See, 2.7. So just verify this. Okay, you'll get 2.7. So this is the interest what I'm going to get, the final interest what I'm going to get. So if I deposit 1 rupees, okay, after, if I compound it 100 times in a year, so after the end of the year my money will be 1 rupees will be 2.7 rupees. Okay, so now the same thing, I tell them I'm little bit greedy. Now I will tell them to compound it 1000 times a year, okay, into 1. So here, in the place of x, just put 1000. So what is the value you are going to get? A is equal to 2.7169. Correct. So if I tell them, just I don't want this much, just compound it 12 times a year. So every month you just compound the interest. So it will be 12 into 1 to the power 12 into 1. So what is the answer I am going to get? So just do the calculation. So I am going to get, if I compound it 12 times, I am going to get 2.613. See here. So here this was compounding after 100 times, correct? If I compounded this 1000 times, I will get this 2.7169, correct? So what if I compound it 10,000 times? So here let it be 10,000 times. 10,000 times into 1 year. So if I just substitute, you just calculate it. So wherever x is there, just insert 10,000. So my answer is A is equal to 2.7181. Correct. So see, you are getting a constant value if you compound it for a higher number. Correct. 2.71, 2.71. So this whatever number you got, right, that is the value of E. So E's value is 2.71. Okay, and that value is known as E. Okay, exponential value. So if you are increasing the compounding, so here what you are doing, so whatever for, so here the same function you can tell. So E is equal to limit x tending to infinity 1 by 1 plus x to the power x. Correct. So this particular type of function, if you are putting the higher values, for higher values, the value whatever you get is constant. So these kind of function are known as exponential. So this is known as exponential. Correct. So now that's how the number E has been originated, okay, by this short experiment. Okay, so this is one way of explaining it. There are many other ways. Okay, so usually our e to the power E is written as like this. So in your first year in miscellaneous exercises and all, you would have this in sequence and series chapter. So this is how exponential function. So see, these all are not required to be known to solve this derivative. And what it is found is E's value lies between 2 and 3. Okay, you know the E's value, just now we calculated, it is 2.71 something, correct? This is the value of E. So if you want, you can just Google and check. Yeah. So it is 2.718. Correct. It's a constant number. Yeah. So now let's understand what is logarithmic function. So see, we know exponents, correct? So if we have 10 to the power, Okay, 10 to the power 1. What is the answer? It is 10. Correct. So if I have 10 to the power 5, what is the answer? After 1 there are 5 zeros. Correct. So see, if I have bigger number 10 to the power 20, there are many number. So see, is there any such kind of function, if I apply it I can know the powers? Okay, there is such kind of function. That function is known as logarithmic function. Okay, so there are some properties of logarithmic function. So here, so imagine 10 to the power 3, it is 1000. Correct. So if I apply log 1000, okay, so what answer I will get is 3. So if I apply log to any number, okay, so it will give me the power of it. Okay, such kind of function are known as logarithmic function. So if I apply log function for 10,000, the answer I will get is 4. But you have to note one thing: whenever you write logarithmic function you have to specify the base. Okay, so if log base 10 this number, then this is correct. Okay, so similarly I can take this example. Yeah, so 2 to the power 3, what is the answer? It is equal to 8. Correct. So log base 2 8, if I find out, okay, my answer will be 3. So it is something like this: log of 2 2 to the power 3. So what it will give me is the answer whatever I have. So here, like this it works. Okay, so what is logarithmic function? Let's see its definition. So logarithmic function, let b greater than 1. Okay, so b means whatever in exponential function we saw, right? That is the same thing. So let b greater than 1. Okay, be a real number. Okay, and see, we say that logarithm of a, logarithm of a to base b is x if b to the power x is equal to a. Okay, so now see, log of this term, log of a, you are applying log to a. So if you apply log to any function a, what you will get? You will get power as your answer. So this same thing can be written as log base b of a is equal to x. So this is the definition of log. Okay, so let's analyze some more example for this. So here just now I gave you example 8. So this I can write it as log base 2 8 is equal to 3. So let's see this example. So 625, I can write it as 5 to the power 4 see, like whatever I'm telling, is it boring? Should I just go to the problems? So I'm just trying.
No, sir, it's interesting.
Okay. Yeah. So now 625. Let's analyze this number. So this number can be written as 5 to the power 4, which is equal to 25 to the power 2. Okay, now see, here if I apply log base 5 625, so what is the answer I'm going to get? The answer I'm going to get is 4. For the same thing, if I write log base 25, the number is 625. What is the answer I'm going to get? It is equal to 2. Correct. So writing the log is not important. So at what base you are doing, that is important. So there is a trick actually. you can convert. There is a relation between logarithmic and exponential function. Log and exponential function. Okay, so see, usually in our textbook exercise and problems, whenever we solve a logarithmic kind of problem, they just write log of something, log of x, correct? If they don't specify any base, then it means by default the base is 10. Okay, if they don't specify the base, it means by default the base is 10. So log x is equal to log 10x, both are equal. Okay, and see, sometimes they write it as lan. So lan of x, so lan means natural logarithm of x. So lan, so natural, which is our natural exponential number? The small letter e, whatever we found out, right? This is our natural exponential number. Okay, and that lan x can be is related to log x in this way: log base small letter e of x. Okay, if your base is e, then it is lan x. Yeah, now how can you convert logarithmic function into exponential function? So now if I have log x is equal to a, okay, log x is equal to a. So to convert into, so what is x equal to now is my question mark. So if I want log to convert into a, I have to, what I have to do? Log, when it goes to right hand side, what it becomes? It becomes anti-log. Correct? In physics you have used, correct, anti-log in your physics problems in first year and all, you have might used anti-log a. So what does this anti-log means? Okay, so anti-log is just a name. Okay, actually what it is it is 10 to the power a. Okay, 10 to the power means anti-log, that's it. So if you want to convert log to anti-log, log to exponential, you have to do it in this way. So here if you apply log x, what is the answer you are going to get? A, correct, you will get the answer a. So how to convert log into exponential function? Just write down 10 to the power whatever right hand side, x is equal to 10 to the power whatever term is there in the right hand side. This is how you convert logarithmic function in terms of exponential function. So what if you have like this: lan x is equal to a. So here what is the base here? Log base e, correct, e of x is equal to a. So here if you want to convert into exponential function, so x is equal to right hand side, so whatever base is there, no, base to the power right hand side. That's how you convert log function to anti-log function. Okay, so here if you apply lan e, lan e to the power a, so whatever answer you will get is this. Okay, lan I think I have missed something. Yeah, e to the power a, is it proper? Yes, x is equal to e to the power a. So if I apply, yeah, it's proper. Okay, just don't focus on this. Okay, yeah, so this is how you convert logarithmic function into this. Yeah, so these are some basic rules, and some logarithm has some properties. Okay, so the first property is, if you have log base a p, okay, this you can write it as in this way. So this formula you use very rarely. Okay, so here log base a of p can be written as base of some another number in this form. Okay, so for example, log base 10 of let it be some known number, 10 to the power 2. Okay, let it be 10 to the power 3. So now this thing you can write it as some other numbers base. So log base 5, what is the value in terms of p, what is the 1000 base 5 a. So a means 10. So you can write it in this way. So I can take some another number also. Yeah, so this is one of the property. Okay, so you can write it in another term. So these kind of function are, see, you might not be using this much frequently, and this might be used in some competitive exam and all. But see, whenever you go to your higher studies and all, okay, so you have to do some computer programs, correct? So in computer programs and all, some computer programs are designed in such a way that can understand only log base to 10. Okay, that can understand only log base to 10. Okay, and if your problem is given, if some problem is given in log base e, how can you write the same? If you write this input, it will not understand it as log base 10, it will understand as log base e of this function. Okay, so in that time what happens, these kind of conversions are useful. Okay, so especially while you are solving some physics problems using computers and all. Okay, so there is I used one software called Maxima. So in your higher education you can you will come across these softwares and all if you are taking degree and all. So in MATLAB there is another software called MATLAB and all. So in those softwares, whenever you are solving problems of logarithm and all, it will only identify log base 10. If you are giving log base e, you cannot solve. So how can you convert log base e to this? So do you know there is a shortcut trick? Log base e of x you can convert into log x. It is 2.303 log x, log base 10x. Okay, this is the shortcut formula. If you want to derive this, how it is, just apply this, the definition what we saw above. Okay, so log base e of x, it is like writing log, if I want to write in terms of log base 10 x divided by log 10 of e, correct? So just calculate this log base 10 of e, that value will be 1 by log base 10 of e, that value will be 2.303. Okay, just find out it, you will get your answer. So 2.303 log x you will get, log base 10 of x. So this is how you can do the conversion. Okay, so this, while solving your numericals, it might not be much useful. Okay, but other two formulas I am going to tell, that are very useful. So the another formula is this. So if you have log of p into q, okay, so you can split it as log p plus log q. Okay, this is the formula you are going to use frequently while solving the derivatives. And if you have some formula like this, log x by y, then this is equal to minus log y. Okay, so these two are very important formula. And see, log x plus y can be written as log x into log y. Okay, this kind of relation we are going to use very rarely. And there is similarly another, yeah, that is not required. So these are some basic identity. And always remember this. Okay, so 10 to the power, if I have 10 to the power log x, the answer is x. So what happens here is, this is anti-log, this is log, log and anti-log will cancel, only x will remain. Okay, so if I have e to the power ln x, so what happens is e and ln will cancel, only x will remain. So if you want to find out, you can just verify it. So 10 to the power log, if I do 1000, so what is the answer I am going to get? My right hand side will be 1000. How it is? So log 10, log 1000 is how much? 3, correct? Log 1000 is 3. So 10 to the power 3 is how much? 1000. So see, 10 and log gets cancelled, only 1000 will remain. The same is applicable for here. E to the power ln x is equal to x. So this and this will always cancel. Okay, so these are some properties of logarithm function. So I hope you understood this. Okay, so these are just introduction to logarithmic function and exponential function. So in the next class we are going to differentiate this logarithmic function and exponential function. Okay, using our previous rules and some new rules of differentiation. Okay then, so do you have any doubts?
No, sir.
No, sir. Okay.
No, sir.
So you can leave the class. The next class is on tomorrow.
Thank you, sir.
Thank you, sir. Welcome.